We know how to work out the equation of a straight line. We're now going to look at how we can work with parallel and perpendicular lines. In this example question, we want to find the gradients of lines A and B, and then write down what we notice about that answer, or notice about the lines. Now, if I look at line A, it's got 1, 5 and minus 1, 1 on the line. So to work out the gradient of A, so I'll say M with a little subscript A, this is going to be y2 take away y1, so 5 take away 1 over 1 take away minus 1, x2 take away x1. This is 4 over 1 minus 1 is 1 plus 1, which is 2. 4 over 2 is 2, so M sub A is 2. And the other line, so this is line B, to work out its gradient, I'm going to do, so let's scroll down a little bit, there we go, y2 take away y1, so 3 take away minus 3, over 2 take away minus 1. This is going to be 6 over 3, which is 2. But these numbers are identical. I've got the gradient of A is 2 and the gradient of B is 2. And just looking at the lines now, we should notice that these lines are parallel. Remember, gradient just means the slope of a line. So if two lines have the same slope, they should have the same gradient. And if two lines have the same slope, they've got to be parallel lines, as shown. Now let's have a look at a different example. So line B has the equation minus 2x plus 3, and line C has the equation x over 2 plus 4. B is the blue line and C is the red line. We want to work out their gradients first, and then work out what we get when we times those two gradients together. Now, we know from the equations, so line B has the equation minus 2x plus 3, so I can say the gradient of B is m, that's the coefficient of x minus 2, and the gradient of C, because it's x over 2 plus 4, that's just a half x plus 4, so the gradient of C is a half. Now, if I take their gradients and multiply them together, so mb times mc, I get minus 2 times 1 half, which is just minus 2 over 2, which is minus 1. So when I times their gradients together, I get minus 1. And looking at the lines, we can see that they are perpendicular. They're at right angles to each other. And this pattern, this rule, that the product of the gradients is minus 1, is correct for any two lines that are parallel. These are our results. Parallel lines have equal gradients, and for perpendicular lines, the product of the gradients is minus 1. Now let's have a look at some GCSE examples. These would be grade A or A star questions. For example, line X passes through the points 1, 3 and 3, 9. Line Y is parallel to line X and passes through the point 4, 5. We want to find the equation of line Y. Our strategy is going to be to first find the equation of line X. And you could think of this with a little sketch actually. So if line X is this line, no idea if it has even a positive gradient, but there we go. So there's line X. Line Y is parallel, so that means we know that it's going to be somewhere like that. It could be above X or below it, but the point is they're going to be parallel. So if I find the gradient of X, automatically I'll have the gradient of Y. Let's find the gradient of X. So it's going to be, if I call this my second point B and the point further to the left, 1, 3, my first point A, I have 9 take away 3, y2 take away y1, over 3 take away 1, x2 take away x1. I get 6 over 2, which is 3. So the gradient of line X is 3. But because Y is parallel to line X, it's also got gradient 3. So I can say the gradient of Y is 3. So the equation of line Y is going to be Y equals 3x plus C. But I do not know what C is. The only thing I really know about Y, other than the gradient, is that it passes through the point 4, 5. So that could be there, for example, 4, 5. So what that means is when Y is 5, X is equal to 4. So I can say 5 equals 3 times 4 plus c. So 5 equals 12 plus c. And to get c on its own, I subtract 12 from both sides, which will give me minus 7 for c. So therefore, the equation of y is y equals 3x, mx, 3x, take away 7. And this is probably the hardest type of example they could give you. Line P has the equation y minus 3x minus 5 equals 0. Line Q is perpendicular to P and passes through the point 6, 10. We want to find the equation of line P. This is probably the hardest type of example you could see. Line P has the equation y minus 3x minus 5 equals 0. Line Q is perpendicular to line P and passes through the point 6, 10. We want to find the equation of line Q. The first thing we need to do is write down the equation of line P in the form y equals mx plus c. To do this, I'm going to add 3x and 5 to both sides. This will give me y equals 3x plus 5. So now my equation of line P is in the form y equals mx plus c. So I can see the gradient of P is 3, and I can see the y-intercept of P is 5, but that doesn't really help us here. We know that line Q is perpendicular to line P, so I can say that if I take the gradient of P and I times it by the gradient of Q, we are going to get minus 1. But the gradient of P is 3, so I can say 3 times the gradient of Q is minus 1. Therefore, to get the gradient of Q on its own, I would divide both sides by 3, giving me the gradient of Q as minus 1/3. So the equation of Q is going to be y equals minus 1/3 x plus the y-intercept of Q. I don't know what that's going to be, but I do know that Q passes through 6, 10. So when x is 6, y is 10. So I can say 10 equals minus 1/3 times 6 plus c, which means that 10 equals minus 2 plus c. To get c on its own, I would add 2 to both sides. So I can say c equals 12. Therefore, the equation of line Q is y is equal to minus 1/3 x plus 12. Here are some questions for you to try. Please pause the video now and have a go at them. And when you're ready for the answers, press play. Just one hint for question 2. Make sure you can rearrange to get y as the subject first. Actually, that helps you with both of them. Make sure you can get y as the subject in both cases. If not, make sure to review the video on changing the subject of a formula. So pause the video now and have a go. And when you're ready for the answers, press play. Here are the answers. You should have y equals 2x minus 5 for the equation of line Z and y equals 4x plus 11 for the equation of line R.